Let's look at the section 2.8. This section talks about logical equivalence. Right? Let's look at the notation. Right? Statement R is logically equivalent to, say, statement S. If R and S have exactly the same truth table. Alright, so let's look at an example. Right, so there are actually three of them are all logically equivalent. So P implies Q is logically equivalent to not Q implies not P, which is logically equivalent to not P or Q. Right, so let's look at that. So write all possibilities. So true, true. Right, true, false. False, true. False, false. Right, there are four possibilities. Right, we've done P implies Q, so true implies true is true. True implies false is the only way this can be false. False, false, so these are all true. So implications are true. Right, not Q is just the reverse of that, so negation of Q would be false, true, false, true. Negation of P would be true, true, false, false. So true, false, 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 true, true. All right, so let's look at the not Q implies not P. All right, so false implies false, so that's true. True implies false, so that's false. False implies true, so that's true. True implies true is true. Right? And a Q implies P. This is actually not involved, but I'd like to go over it since we know that this is original. P implies Q is, say, original, conditional. Right? Then not Q implies not P is called the contrapositive. All right? And Q implies P, so it's just a reversal of original. It's called converse. All right, so let's look at the Q implies P. So Q implies P, true, true, so that's true. Right? False, true, so that's true. True, false, that's false. False, false, that's true. All right. Also, let's look at not P or Q. All right, not P is false, then Q is true, so that's gotta be true. Right? Not P is false and Q is false, so it's false. All right, and not P, so not P is true and Q is true, so that's true. All right. And not P is true, Q is false, so it's true. All right, so this is that. Then let's look at the truth values. All right, P implies Q, so that's the original implication. It has true, false, true, true, and which is equivalent to not Q implies not P, which is the contrapositive. So you can see that it has exactly the same truth table, right? But you can see that here, converse is not logically equivalent since truth table here is different from truth table for original or contrapositive. However, not P or Q actually has exactly the same truth value. So therefore, P implies Q is logically equivalent to not Q implies not P, which is called the contrapositive, which is equivalent to not P or Q. So those are equivalent. All right, that's it. I hope that this was clear.